Center, Technology, Research and Management, Ahmedabad. Prior to joining IIT RAM, he has served as faculty Mechanical Engineering Department, BITS Pilani, for more than 7 years. He is the member of IMEC-E, IIR, ASHRAE and ISHMT. He is holding the position of refrigeration chair for ASHRAE Western India and ASHRAE Ahmedabad. His area of research is on optimization of eco-friendly and energy-efficient refrigeration systems, such as CO2 refrigeration systems, evaporative cooling, cold chain, indoor air quality, etc. He has published more than 20 papers in various reputed journals and international conferences in India and abroad. So I welcome Dr. Dilip Gupta for today's session. Hello Dilip sir, can you hear my voice?
Hello.
Okay.
Thank you very much for the introduction. I'm just trying to share my slides.
Okay sir, waiting. टेक्स्ट किया उन्होंने.
My slide is visible?
Yes, sir, it is visible, sir.
Okay, thank you. So, thanks once again to the organizing team. Now, with today's session, we'll start with the multi-criteria decision making. So, as of now, yesterday's session we had discussed about the basics of statistics and some basics of design of experiment along with Gauchi method, right? Here, now we are trying to discuss about the some decision making criteria and its application. What are the multi-criteria decision making which is used for different applications that will be discussed in upcoming sessions, and different methods of decision making will also be trying to cover. Let's start with what we have already done. Glimpse of statistics we have done, and Professor Arshad has nicely described this data and what are the definitions of statistics along with the application where it can be used and why it is important in the engineering applications, as it is in mathematical basis, but it can be applied to the actual technical problems, engineering problems, and other non-engineering problem also. Representation of data, analysis of data, and different method where we can analyze how we can analyze the data using these statistical techniques will be discussed earlier. After that, It also has been discussed about the correlation in different type of statistics. What are the correlations of one variable to another variable on the output or the objective function what we have framed. At the same time, there is the discussion of INNOVA, which also discuss about the or gives a glimpse of what is the sensitivity of individual variables on the output what we are going to fix based on the correlation between two or multiple variables what we have finalized or the objective depends on. Going ahead, design of experiment has also been covered where we can reduce the number of experiment in actual condition. So that will drastically reduce the number of experiments and subsequently the time and the cost of experiment by using a design of experiment and its methods. Where we first plan the taste, then what output to be measured with different number of tests that will be depending upon the DOE. Then identify the significant factors based on the ANOVA analysis. Then build up a model of objective function as if we are taking y is an output. Then what the variables is the function of x1, x2, x3. These are the variables. Then we'll check the model and then finally we'll optimize this model by using different optimization techniques. Apart from that, the Taguchi method has been used to design the number of sets of parameters along with the experiment. Right. So, how many experiment to be performed if we are having n number of variables with n number of labels. Right. So, m into n is the total values, but it can be the same result can be drawn by using a small number of experiment, significantly small number of experiment by using the Taguchi method that has been discussed by Dr. Abhishek also. Whatever we have discussed as of now was based on the single objective. Doing all those things, we can identify a set of objective where individually this objective will be analyzed. Suppose we have discussed I want to measure the power output, and power output should be maximum for a particular system. And this power output is a function of three different variables, right? So these three different variables will be having different labels, and we can decide the label and we do the analysis. But at the end of this whole analysis, what we are getting is the power output only. If we want to analyze the power output, we want to analyze the power input, and then finally efficiency. To individually three times, you have to repeat this method, and individually we will get the sets of conditions where you are getting the maximum power output, minimum power input, and maximum efficiency. This is what how you can apply whatever you have studied as of now. So here, what we are able to do is we can work on only one parameters, only one output parameters at a time. However, in actual conditions, sometime the situation will come when we have to analyze the multiple objectives, or we have to work on multiple criteria, and simultaneously you have to see the effect. It may be possible that one factor is like we are talking about the power output and whatever the consumption as power input and efficiency. If you talk about anywhere, the actual condition is power output should be as high as possible is the desirable condition. Power input should be as low as possible is the desired condition, and efficiency should be as high as possible for any machine or any system. Now these three are the conflicting parameters. You can see one is higher is better, another is lower is better, then again another is higher is better. And simultaneously you want to work for this objective. Then this objective can be simultaneously analyzed by using the multi-criteria decision making. Am I clear?
Yes, sir. Yes, sir.
How where it can be used. To the multi-criteria decision making, that is called as MCDM in short, or sometimes it is also termed as multi-criteria optimization. Name itself indicate multiple criteria, right? So multiple criteria are involved on the decision making. For any system, if you are going to select something, if you want to buy a mobile, What are the criteria you are going to take a decision? Whether I have 5 options, the 5 mobiles are available with us in front of you. Then what are the criteria? That will depends on individual decision maker. Somebody will think, yeah, cost should be low. Somebody is thinking, okay, cost, I can compromise with the cost. I can go for higher cost. But the function should be good. Somebody is talking about the brand. Somebody is talking about some other features. Somebody is talking about the looks and it's appealing in nature. So these are the criteria. So multiple criteria are there. Now, if you will analyze the individual mobile, you may get ki some is lower cost, some is higher cost, some is medium cost. Somebody, as far as the feature is concerned, it will also be rating as very high, very good in a lower category. Similarly, looking point of view is very good, medium or low. So in that way you are having the huge number of criteria. Now you want to make a decision on that, which one is the better, so you will apply a multiple criteria decision making out of that. Sometimes it happens that this criteria will be conflicting in nature. Conflicting in nature means what? One criteria is good for us, but other criteria is not good for us. Like if I'm talking about the cost should be as low as possible, which is desirable. But at the same time, when we talk about the feature should be as good as possible. So these two are the conflicting criteria, right? So you have to apply a multiple criteria decision making over here, and you can make a decision in the quantitative term. I'm using term quantitative terms. So whatever the criteria you are taking, that criteria may be quantitative, it can be qualitative also. And all the criteria of quantitative and qualitative can be converted in a single platform, a single term, in a standard form, in a quantitative term. Once it will be converted in quantitative term, then we will find an aggregate based on the aggregate score, you can say, based on the individual, based on the different methods, using different methods. And these criteria will be converted in a single criteria as an aggregated term, and we can rank those criteria. We'll rank those alternatives, other criteria. Based on the criteria, we'll rank the alternatives available with us, and whichever is having the highest value will be treated as this is apart within these given criteria or defined criteria. This is the best possible solution or best product for the selection. So multiple criteria decision making refers to making a decision in the presence of multiple or usually conflicting criteria. This is the definition of multiple criteria decision making. This also in short form it is known as MCDM. Let's understand by another example that if being a student, if you are going to get admission on a college and you want to select which college should I select for admission. So what are the possible criteria over here? While selecting being a student, the criteria maybe you will think about what is the rank of this institute. Maybe an IRF ranking, you are going for accreditation or some other criteria you will fix based on that ranking. You can pick. Another criteria you can fix like that particular branch is available or not. What you want to take. प्लेसमेंट क्राइटेरिया कैन ऑल्सो बी अनदर क्राइटेरिया कि प्लेसमेंट कितना है, प्लेसमेंट अच्छा है तो ठीक है, नहीं है तो आप उस पर जा सकते हैं. देन यू विल सी कि टोटल ओवरऑल कॉस्ट क्या है. जो फीस के टर्म में आप देखें तो ओवरऑल कॉस्ट कितना आता है आप अगर एडमिशन लेते हो तो दैट आल्सो कुड बी एन क्राइटेरिया. सो इट्स इम्पोर्टेंट these all criteria are there. Now you have 10 number of college in the list. Different colleges are in the list. So 10 colleges will be considered as an alternative. I have 10 alternatives, out of that I am going to select. And I am fixing some criteria like economical criteria, placement is another criteria, ranking is another criteria, and number of student, mess facility, hostel facility, so and so. Right? So these number of criteria are there. Now you will see somewhere placement is very good, this is very high. Hostel facility is not good. Somewhere hospital facility is good, placement is very low, fees is very high. So these are conflicting criteria. One criteria is better, one criteria is worst for that condition. So these conflicting criteria will be placed together and make a decision matrix for that. And these decision matrix will be used for the analysis of multi-criteria decision making. Now we'll apply the multi-criteria decision making over here. give the complete, prepare the complete decision matrix in terms of quantitative term. Once the quantitative term will be available, then these can be scaled up in a single reference point, a single scale between 0 to 1 maybe. So after that, this will be a standard decision matrix, and this standard decision matrix can be used for further analysis and doing the multi-criteria decision making by using different metrics, different techniques of multi-criteria decision making, which we are going to discuss the individual method in the subsequent sections in the coming sessions. So these are the probable criteria that one can think as a student, that what is the distance from home, college का distance कितना है, accommodation की options है कि नहीं, quality of faculty क्या है, on campus placement record क्या है, total admission के expenses कितनी हो सकती है, number of students are available in that particular branch where they want to take. Then apart from that, you may have the college infrastructure, library, learning tools, facilities, sports facilities available for extracurricular activities or not. So these could be a criteria, and this criteria will be used for the decision making. This is one example. Another engineering example, you can take the selection of material for engineering application. So suppose I want to select a material for particular applications. So there are certain requirements certain requirements for that particular application, like core hardness, surface hardness, bending fatigue limit, ultimate tensile strength, surface fatigue limit. These are the criteria for the as a properties of material. Out of these, some criteria will be higher is better, some criteria will be lower is better as per the application, different application. Now, out of that, if you want to select, then again the similar way you will create a decision matrix, including suppose n number of materials are available with you, suppose 10 number of materials are available with you, and individual has individual core hardness, surface hardness, bending fatigue, ultimate tensile strength, and surface fatigue limits, and that could be different for all cases. You will find some cases core hardness is better, but surface hardness is not fit for particular condition, or fatigue bending limit is not fit for particular conditions. So these criteria will be creating used for creating a decision matrix, and finally we'll apply the multi-criteria decision making for taking out the best material for that particular application. So this is the selection of engineering materials for engineering application. Can another example for multi-criteria decision making. Going ahead, depending on the whether problem is design oriented problem or selection oriented problem, this MCDM techniques, that is multi-criteria decision making method, can be broadly classified into categories. The first category is multi-objective decision making, and second criteria is the multi-attribute decision making. Multi-objective decision making means what? You are working on the design problem. Like you want to design a particular component which must have a particular performance parameter. Like इसका जब आप इसको यूज कर रहे हो तो इसमें इतना हार्डनेस होना चाहिए, इतना आपका टफनेस होना चाहिए, these are that, or it can take the load of this much kilo kg, or it can sustain this much amount of torque or bending strength. So these are the criteria which will be objective oriented. So ये आपका quantity term में होता है objective oriented जब बात करते हैं, right? When you're going for attribute decision making, MADM technique, it means that you're talking about the selection of problem. Selection means what? मेरे पास data available है, मुझे सिर्फ select करना है कौन सा better है. Objective function मैं define नहीं करूँगा इसमें. इसमें objective होता है, इसमें क्या होगा कि आपने एक suppose एक function बनाया, y is a function of different criteria x1, x2, x3 like this, right? So this is objective oriented. आपका डिजाइन प्रॉब्लम में हम जनरली यूज करते हैं मल्टी ऑब्जेक्टिव डिसीजन मेकिंग. Multi attribute decision making generally used for the selection problem whenever you are having the n number of alternatives along with the n number of criteria, just like as a selection of college, selection of engineering materials that I have given as an example. So here I will use the multi attribute decision making. Attributes itself indicate this criteria as whatever you're using here is known as attribute here, right? So let us discuss with the multi-attribute decision making. It is in short form, it is known as MADM technique. MADM technique, other hand, is generally a discrete in nature. Discrete in nature means what? It is in a fixed boundary. Limited number of predetermined alternatives are there. Like for an example, I am saying 10 colleges are there. Where among these 10 colleges, I am going to select one as the best using this technique. So these 10 alternatives are predefined that I have only 10 options. Out of that, I have to select. MADM approach is MADM is an approach of problem solving that implied to solve the problem involving selections. So whenever selection criteria will be involved here, we'll use the MADM technique. Among the finite number of alternatives, as I said, n number of alternatives are there, 10 colleges are there, 5 materials are there. Out of that, we are going to select. MADM method is specifies how attribute information is to be processed in order to arrive the choices. Generally, it is a scientific method to convert the data which is available at decision matrix to a single parameter, and it can be used to select the best possible out of the given option. That is, I said, defined a definite number of alternatives. 10 alternatives are there with different criteria. We can find out. Any problem? Hello? Am I audible? So this is to reach the best possible solution to write the best choice by using a multi-attribute decision making. Each decision table is called as decision matrix, as I said, and here there are four major parts. One is alternatives. Alternatives is the whatever the choice we have available, a number of colleges, a number of materials, a number of so and so machines. Out of that, we are going to choose. So this is called as alternative, right? Attributes are the criteria basically. Whatever the criteria we are using for taking a decision and for analyzing the problem, for the selection, making the selection criteria of that. This is called as attributes. Like I am using an example of college. What is the distance from the home, placement, hostel facilities, food, college infrastructure, faculties, quality of faculties. These are called as attributes. This attribute can be quantitative or qualitative in nature. Weight or relative importance of each attribute. This is an important point. Whenever we are using weight or alternative, there is individual decision maker has their own perspective that which criteria should be given how much weightage. Sometimes, if I am taking example of the selection of college, sometimes somebody is thinking, okay, I don't care about how much distance is there from my home. Does not matter for me. So the weightage is very low in that case. If somebody is thinking, no, I cannot go for this higher cost, so that criteria will be given higher weightage. Or somebody is thinking, I want to go to college where 100% placement should be there. So highest. So that time the placement should be given as the highest value. Somebody is talking about the faculty quality. Faculty quality should be good as possible. Or somebody is saying, I don't care about it. Whosoever is the faculty, but I want to go for placement. So placement को ज़्यादा criteria देगा, and faculty quality को कम criteria देगा. Individually analysis आप कर सकते हो criteria के basis पे. So that criteria will be given as relatively. Relatively means what? Total criteria will be given as 100%. Right? So whenever we give the percentage weightage for percentage weightage to individual criteria, always keep in your mind total should be 100% and one will be given as relative to other. So suppose I am giving 30% weightage to the placement, it may be possible other will be 20%, 10%, but net amount or summation of total weightage should be 100%. So in this way, the weightage of weightage or relative importance of individual attribute will be given. That is given by W. Then measure the performance of alternative with respect to the attributes. that is the net aggregate what we are going to calculate for selection or ranking of individual alternatives. It will be considered as a performance measurement for individual alternative, right? So ultimately, if you have the value of a number of alternatives are there, number of criteria are there, we have given the weightage, then we can apply different techniques of MADM, and we can finally find out the total score or aggregate value in a single column for each alternative. Means what? Individual alternative have a individual value, that is score for the individual alternative, and this individual score will be help to rank that particular alternatives. But keep in your mind always here, the highest value will be given as the first rank, whether the criteria are conflicting in nature, whether all the criteria is considered as lower is better. It does not mean the ranking will be starting from the lower side. Always, in all cases, the net ranking will be started from the highest value of measurement of performance, or the overall aggregate what we are getting. Right. So this is about the MADM technique. So decision table or decision matrix will be given like this. So these are the attributes, also considered as criteria or factors. So let us say B1, B2, B3, B1, B2, B3 to BM. These are the number of criteria which you have defined or fixed for that particular for the selection. A1, A2, A3 to AN. These are the criteria. Alternatives for the selection of. Uh, these are the alternative available with you. Out of that, we have to select. And using that, if you are taking with first alternative, what is the value of first criteria or attributes? Suppose I am taking that cost point of view. Cost is suppose right. Cost here is 2 lakh rupees. Suppose 5 lakh rupees, 3 lakh rupees, 4 lakh rupees like this, right? B2, if I am taking the placement criteria, 50%, 70%, 100%, 10%, maybe 40% like this. B3, if you are taking as the faculty quality, good, very good, medium, average, you can give in qualitative term also. Similarly, this way you have to create the this matrix for decision making. So alternative AI is for I is equal to 1 to n. Attributes as Bj is j is equal to 1, 2, 3, 4 m. Weightage will be given for individual cases. This weightage can be given in terms of 10% means 0.1 you can give, 20% means 0.2 you can give like this, right? But keep in your mind the summation of this W should be 1 or 100%. Measurement of performance alternative will be given as Mij for I is equal to 1 to n and 2 is equal to 1 to m. So this is overall the decision table or decision matrix for MADM technique. Once you have this table, then only you can proceed. So the for starting of applying any MADM techniques, this table are important. So this is somehow you can say the forming or framing the problem, right? Whatever the problems are there given in the text form or in the raw materials or raw data, you have to prepare this table as the attributes or criteria and alternative along with the weightage. That is known as decision table or matrix for MADM techniques. Once this table is ready, then you can apply the different techniques for getting the solution. Am I clear? Going ahead, multi-objective decision making. As we have discussed about the MADM technique is used for the selection problem. MADM technique is used for the design problem mainly, right? And it has the decision variable value which are determined in a continuous or integer domain with infinitive large number of choices. Like as we have said that in case of MADM technique there are 10 alternative, 15 alternatives like this. But in case of MODM technique, there is no limitation as such that this is the n number of choices. You may have infinite number of choices possible. Here you have to decide the objective function. For an example, if I am talking about the cost, so objective function is the minimum. Minimum is better. So minimize the cost is the objective function where y1 is given as 2x1 plus 2x 3x2 plus 1.3x3. This is the function. This function has to be objective function has to be first generated based on the data. Once this will be available with you, then you can proceed for the multi-objective decision making criteria. Decision making. Similarly, for efficiency, always efficiency, maximum efficiency is desirable. They suppose objective function you are getting like this. So once this function is available, then only you can go ahead for the analysis purpose. However, keep in your mind this value can be limited or constrained by certain value. Like suppose we are talking about y1 or y2 is a function of x1, x2, x3, and x4. You can limit this x1, x2, and x3 and x4 depending upon the different applications and its feasibility. Like for an example, I am saying x is the speed. The speed of any vehicle, any component, any machine will has a limitation. It can go from 0 to n number of values. It cannot be infinite. So you have to put a constraint like x1 should be, suppose you are taking the speed, the x1 should be within the range of 0 to 300 rpm, 400 rpm, 500 rpm like this. Suppose you are talking about the x temperature. Temperature, suppose I am talking about temperature. Temperature range is starting from suppose 0 to 50, 100, 200, 500. You cannot go for 5000 degrees centigrade. So you can fix up this values as a constraint, and within that constraint, that objective function will be applied, and using MODM technique, you can find out which one is the best possible solution. Means which value will be the best. Yeah. Suppose x1 speed you are taking 0 to 300 rpm, then there is a possibility that any value within that range can be an optimum solution, optimum value. It may be 0.5 also, it can be 299 also, it can be 290.7534 as for whatever you are up to what digit you want to go for accuracy, right? So it could be infinite number within the given range. There is no fixed value कि आपको 0 लेना है, 0 के बाद 10 लेना है, 10 के बाद 20 लेना है, 20 के बाद 30 लेना है, ऐसा नहीं है. It can be any value within the given range in multi-objective function. So most important thing, as in a previous case which we have seen, that decision matrix was the first and important criteria. Similarly here, the objective function is the most important criteria, and finding the range of the individual variables x1, x2, and x3, x4. These are the important criteria for starting the problem of multi-objective decision making. Am I clear?
Yes, sir.
Going ahead, these are the one example of that we have an objective function like x1 plus 2x plus x3 less than or equal to 150, x1 plus x2 plus x3. ये आपके पास constraint दे दिया आपको किस criteria में आपको 150 से कम होना चाहिए, right? So this should be 170, less than 170. This is another one, and out of this is the another constraint. X1 is varying between 0 to 50, x2 is from 0 to 32, x3 is 0 to 44, and x4 is 0 to 18. So now you can say you have to find out the best combination of x1, x2, x3, and x4 by using the multi-objective decision making to obtain the minimum value of y1 or maximum value of i2 within the given constraints. ये constraint आपको follow करना है. उसके बाद आपका ये वैल्यू से आप बेस्ट पॉसिबल कॉम्बिनेशन फाइंड करेंगे x1, x2, x3, x4 का, एंड देन that best combination will be based on minimum value of the cost and maximum value of the efficiency, right? So in this way you will use the multi-objective this is the multi-objective decision making. Conflicting objective optimal solution is one objective does not mean the optimal solution. Means एक अगर आप objective को fulfill कर एक criteria को fulfill कर लेते does not mean that the optimum solution is there. There will be a possibility of infinite number of solution also. As a variable, like आप simplex method में देखते हैं कि there is possibility of infinite solution also. As a variable can take any value within their bound. Solution of this method can be solved by using can be achieved by using a traditional method such as simplex method, quadratic programming method, geometric programming, dynamic programming, etc. And some non-traditional optimization method which we normally use like genetic algorithm, simulated annealing, taboo search, ant colony optimization, artificial bee colony algorithm, etc. There are so many methods to find out the optimum combination using the MODM technique. So these are the non-conventional, non-traditional optimal MODM technique which we normally use for the decision making whenever we are going for design problem generation. In most of the cases, in design problem. Let us start with the one MADM technique here that is called SAW method, simple additive weighting method. This is one of the MADM technique which is invented by the Fishburne in 1967. It's first proposed by the Fishburne in 1967, and it is the one of the simplest method for a decision making, multi-attribute decision making. Here, each attribute is given a particular weightage depending upon the decision maker, and some of this weightage should be one, must be one. Each alternative is assessed based on this equation P. This P value should be equal to summation of j is equal to 1 to m, wj and mij. This mij we are taking from, so first and important thing is you have to create the decision matrix. Once we have decision matrix, then only you will apply this matrix. So we assume that decision matrix is ready with us. Now you will apply the sum method over here. So it will give PI. PI is nothing but it's a composite score for a particular alternatives. So PI will be calculated as summation of weightage, individual weightage, and individual value of MIJ as the value of decision matrix given on that particular problem. This PI, the highest value will be PI will be considered as the best alternative for this. So overall, what we have discussed in multi-attribute decision making, we will again try to find out the overall score as PI, and जहाँ पे आपको highest value of PI मिलता है उसको हम first ranking देंगे, and that will be the best solution or best selection for best alternative for the selection. These are the steps which we normally use for the analysis using the SAW method. Compile the data in actual form. This actual form means आपका जो decision matrix है वो आपका तैयार होता है. Identify the desired result depending upon the criteria. Some criteria will be having lower is better. Some criteria is having higher is better. As I said, cost should be lower is better. Performance or efficiency should be higher is better. Sometimes strength higher is better अकाउंट्स में आएगा. Poor hardness आपका lower is better कंसिडरेशन में आएगा. ये आइडेंटिफाई करके हम रख लेते हैं कि हाँ ठीक है, कौन सा क्राइटेरिया आपका हायर डिजायरेबल है, कौन सा क्राइटेरिया लोअर डिजायरेबल. Once this decision matrix is formed, then we will normalize the data. What does it mean by normalization of data? Normalization of data means what? The data will be available in decision matrix in a different scale. Like for an example, I am taking one example. We are taking the so let us take an example of cost. Cost is given 5 lakh, 3 lakh, 4 lakh, 10 lakh like this. We are talking about the power 1 kilowatt, 2 kilowatt, 3 kilowatt, 5 kilowatt. Talking about the speed 200 rpm, 300 rpm, 400 rpm, 200 rpm, 100 rpm like this. So these scales are different. One is in lakhs, another is in just one digit, another is in hundreds. So these all criteria should be normalized in a single scale within 0 to 1, where the lowest value will be considered as 0 and highest value considered as 1. This data will be normalized, normalized table will be prepared. How the normalization will be done? Normalization will be done by the formula which is given this here, Wij, where Wij will consider as the normalized output for particular value ij. Xij is the given value in actual form. right? So, and we will identify the maximum minimum. This is the actual value which is given for particular criteria. Please keep in mind particular criteria, right? And this is the maximum value for that particular criteria and minimum value of particular criteria, right? For an example, you are talking as cost is the criteria. So, what is the actual cost for that particular alternative? What is the maximum cost for that particular criteria, all criteria, and what is the minimum value for the given criteria, right? So these value will be taken, and this is used for the criteria when it is identifies as lower is better, right? Similarly, when the given criteria or factor is to be higher is better, in that case, in that case, Yij will be calculated at Xij minus minimum of Xij, maximum minus minimum of Xij. So this is two equations which will be used for two different criteria, lower is better and higher is better condition, right? So first, what we are doing, we are having the actual data, then we have prepared a decision matrix, identify the which criteria is lower is better, which criteria is higher is better. Once this criteria has been identified, use these two equation for lower is better and higher is better for that particular criteria. Keep in your mind particular criteria and particular alternative. Start with particular alternative with analyzing the individual criteria. Then once this calculation will be done, the decision matrix will be converted to a normalized data table. Earlier it was the decision matrix, now it has shifted to the normalized data table. And once it is done, then you can find out the overall composite score as using the equation pi is equal to summation of wj and mij. Using this, you can find out the overall score. Once overall score table is ready, now you have a number of alternatives, and these are the score out of that. So scores uske corresponding aa jayega. Which value is highest will be given as 1 and followed by the lower and lower value, which is 1, 2, 3, 4. So highest is 1, the first rank, and the lowest is the last rank, and you can do the ranking. And which one is the highest ranking will be given as the best choice for this particular given conditions. This is one example which has been taken in a previous lecture also, that if we have a data sheet available with us as the cost iron, the materials as an alternatives. So a number of alternatives are there, like cast iron is there, ductile iron is there, SG iron is there, cast steel is there, hardened steel is there, sulfur hardened steel, carbide steel, nitride steel, and hardened carbon steels are there. So these n number of alternatives are there. So 4, 5, 6, 7, 8, 9, 10, 9 alternatives are there. Out of that, we have defined the criteria as core hardness, surface hardness, then surface fatigue limit, bending fatigue limit, and ultimate tensile strength. These are the 5 criteria has been identified. So these are the attributes, 5 attributes for 9 alternatives, and these are the actual values of it. Cast iron, the core hardness is 200, surface hardness is 200, then surface fatigue limit is 330, bending fatigue limit is 100, ultimate tensile strength is 380. Similarly for ductile iron, similarly for SG, then similarly for cast alloy, we are having this. This is basically your decision matrix or decision table in actual form. Now you can see, first we will identify which one is better and which one is lower is better, which one is higher better. In this particular case, the core hardness will be considered as lower is better condition. Other 4 will be considered as higher is better condition. Higher is better condition. So now we have data in different scales. Now we will try to convert in single stage in a standard form by using the criteria lower is better and higher is better. Let us try to solve what is the normalized value of this or this table or this problem. So how you will calculate this normalized value? This is a condition of LB, that is lower is better condition. सो लोअर इज बेटर कंडीशन के लिए हमने क्या रखा था, कास्ट आयरन के लिए अगर कैलकुलेट करते हैं तो ये आपका लोअर इज बेटर कंडीशन में. लोअर इज बेटर इक्वेशन इज गिवन हियर. Yij is equal to maximum value of Xij, maximum value of Xij. So out of this, which one is the maximum value? You can see 315 is the maximum value here. And Xij, this is the actual value. So actual value is 200 here for cast iron. And minimum value is 185 here. So use these three and you will find out Yij will become the normalized value for the cast iron. So these are the values which we have. You'll find out the value. This 0.8846 as the normalized value for lower is better condition in cast iron for the core hardness, right? Similarly, if you are trying to find out the surface hardness in the similar way, here the equation is slightly different because the case is higher is better. So Xij is the actual value, तो ये आपका 200 हो जाएगा. Xij minimum, यहाँ minimum आपका है 185. Then maximum value is here is around 750 here. Now use this equation, you will find out the value of normalized value. So these are the values here which we are going to select, and we will try to find out the value of Yij, which value is coming as 0.0026459 as Yij. In similar way, you can find out for individual attributes along with the individual alternatives, right? So by using this, you will have the normalized data table here. As the cast iron, the value is coming 0.8846, then 0.026, then these values are 0. You can see why these values are 0. Why these values are 0? Some cases you can say values are 0. Here. If you see all the criterias having 1 0 value and 1 1 value, what is indicate? Therefore, these are the 1 value. So these are value 1 and these are the value of 0, right? So what does it mean? It means the whole data has been converted to a standard form of 0 to 1, and wherever the minimum values are coming will be considered as 0, and wherever maximum values are coming is considered as 1. You can see in previous slide also. You can see in this case here the value is minimum here out of this data, and value is minimum here out of this data. तो जहां जहां मिनिमम आया है वहां जीरो आ जाएगा आपका, राइट? जहां पे भी आपका वैल्यू जीरो मिनिमम आता है, हियर आल्सो यू कैन सी मिनिमम, आई थिंक, राइट? And wherever maximum values are there, you can see this is the maximum value, right? Probably this will be the maximum value, and here this will be the maximum. Wherever maximum values are there, where it will be 1. So you can see these are the 1 value, this is 0 value, means whole data has been normalized in the form of 0 to 1, and this is in single scale. Once it is becoming a single scale, now it can be simply applied saw method for cast iron that Pi is equal to 0.866 into 0.2. Please keep in mind here in this particular problem I have taken the equal weightage. Right? If you do not have any information about the weightage how to take, or you don't have any idea how to take the weightage, you can simply take the equal weightage. So 5 attributes are there. You can take 1 by 5 as 20% weightage of each. So 0.2, 0.2, 0.2, 0.2 is the weightage for individual conditions. Now take the summation of this weightage is 0.2 and the value is 0.884615. So you will have the summation of this plus similarly summation of 0.026549 multiplied by 0.2 and 0 multiplied by 0.2 here is 0. So you will get 0.018223. Similarly you can do for all the materials here. So what you will get another table here. That will be the overall score for individual alternatives. Once we have individual, score, so all the data has been converted to a single value in quantity term. Now we will have the data here as cost iron is getting the overall score of 0.1822. Ductile iron is getting in the 0.2654. The similar way. So now what exactly? Now you have the overall score. Now you can get the carburized steel is having the highest score. So you can say out of the given criteria and given alternative, the carburized steel is the best option for the selecting as a material for a particular application. Particular application why I'm using every time because better and lower is better criteria will depend on the particular application where I'm going to use, right? So this is the first. Then you can rank as second. Second rank will be this. Second rank is this. Then this is the third rank. This is second rank. This is first rank. And then you can go for fourth rank, fifth rank, and this is sixth one, seventh one, eighth one, and ninth. Right. So this is about your SAR method we have discussed here. Now, the ranking table for the given value. Right. So this is rank 1. So here the SAR method and MADM technique, introduction to MADM technique is over. So any problem here? Any question for using this type of selection problem? Applying the SAR method and MADM technique. Hello. Is clear?
Yes, sir. It's clear, sir.
Or anything? Any question from your side? So take a break of 10 to 15 minutes. Then the second method is fine. Am I audible?
Yes.
Yes, sir. Yes, sir.
Can we take a break of 10 to 15 minutes? Then probably
Okay, sir.
Okay, sir.
Okay.
है ना, तो इसके बाद हम दो मेथड इसके आगे का सॉल्व करेंगे, दैट इज ग्रे रिड्यूक्शन probably, and let us see which one is suitable.
Okay. No problem.
Right? Okay, thank you very much.